You ever wonder what the difference is between a tiny fender bender in a car getting totally written off, or, a cracked phone screen versus a lucky escape? Well, it's not just luck, it's physics. Today, we're going to hack the crash to uncover the hidden science behind every collision and how a simple, clever loophole in the laws of motion is the key to building a much safer world.
Oh, we've all been there, right? That absolute heart-stopping moment. That slow motion horror as your phone slips, tumbles, and just heads straight for the concrete. But what happens in that split second of impact? It's not just bad luck.
It turns out, the fate of your screen is actually decided by a set of fundamental physical laws. And the best part about a physics problem is that it almost always has a physics-based solution.
So, to find that solution, we first have to really get a handle on the problem itself, because the forces that decide whether your phone survives are the exact same ones at play in every single collision. Everywhere, all the time.
Some are pretty simple, like a ball bouncing. Others are unbelievably complex, like a multi-car pileup on the highway. But here's the thing. Whether they're simple or complex, they are all governed by the exact same set of rules.
And the scale of these things can be just immense. What you're looking at is Meteor Crater in Arizona. It is nearly a mile wide, and it was carved out of the Earth by one single impact about 50,000 years ago. A truly massive collision. But believe it or not, it still followed the same rules as your phone hitting the floor.
So, what are these universal rules? Well, you probably learned them back in school. They're Newton's laws of motion, and they give us the complete blueprint for understanding any crash you can imagine.
Okay, so the most crucial law for collisions is definitely the third one. It basically says that forces always come in pairs. When your phone hits the ground hits your phone back with an equal and opposite force. It's always a two-way street.
Now, this law points out something that a lot of people get wrong. The forces in a collision are always equal, but the effects of those forces, they're not. Think about it. A bat hits a softball. They both feel the exact same force, but the ball is so much lighter, its mass is smaller, so it accelerates like crazy. It's the same reason the meteor was completely vaporized while our massive Earth just got a little dent. Equal force, totally unequal outcomes.
And that brings us perfectly to the second law, the famous F equals m. This equation explains why those outcomes are so different. It tells us that an object's acceleration, how much its motion changes, is a direct result of the force you apply to it and how much mass it has.
Just take a look at this. We've got 3 robots, and they're all kicking identical soccer balls. You can see the blue robot applies the most force, which gives its ball the biggest acceleration. And boom, it sends it flying the farthest. It's just simple cause and effect, exactly like F equals ma says.
And finally, we have the first law, which gives us this concept called inertia. It's a really simple idea. Objects just want to keep doing whatever they're already doing. A moving object wants to stay moving, a still object wants to stay still.
And this idea of inertia, it's exactly why car crashes are so incredibly dangerous. The car itself might hit a wall and stop instantly, but your body, because of inertia, wants to keep moving forward at 60 miles an hour. That is why we have seatbelts. Their entire job is to apply a force to overcome your inertia and stop you safely.
Okay, so we've got these 3 fundamental laws, but when you put them all together, they seem to create this puzzle, maybe even a contradiction, that brings us right back to your phone.
So here's the big question. If Newton's third law is true, if the forces are always equal, then how on earth does a phone case actually do anything? The ground is always going to hit back just as hard. It seems like an unbreakable rule. But it turns out engineers found a brilliant loophole.
This, right here, is the secret. While you can't change the total force in a collision, you can change how long that collision takes. And by stretching out that moment of impact, you can drastically reduce the damage.
All right, let's look at the actual numbers here, because this is where it gets really cool. We have 2 identical objects, same mass, same change in velocity. The only difference? Object B's collision lasts just 1,000th of a second longer. Just by doubling the time of the impact, a tiny fraction of a second, look what happens. The resulting acceleration is literally cut in half, and less acceleration means way less destructive force.
This is the golden rule for surviving a crash. It's the difference between hitting a brick wall and hitting a giant marshmallow. In both cases, your change in speed is the same. You come to a complete stop. But the experience is, well, very different. Less acceleration means less force felt at any given moment, and that means less damage.
And this one single idea, stretching out the time to reduce the force,
It's the secret sauce behind pretty much every safety device we've ever come up with to protect ourselves from an impact.
You know, nature actually figured this out ages ago. A bird that wants to crack a clam knows to drop it on a hard rock. The rock doesn't give it all, so the collision is super short and the force is huge. It shatters the shell. But if that bird dropped the clam on soft sand, the sand would squish and deform, extending the collision time, and the clam would probably just bounce and be fine. And of course, engineers use this exact same trick all over the place. A car's crumple zone isn't a design flaw, it is specifically designed to buckle and fold to make the crash last longer. A stunt person's giant airbag, a gymnast's mat, even the foam in a shipping box, they all do the same thing. They deform to increase the duration of the collision and, in doing so, reduce the force.
Which brings us all the way back to our phone. That simple little case is actually a brilliant piece of engineering that hacks physics. The soft material compresses on impact, and that extends the collision by just a few milliseconds. And that's a tiny, tiny amount of time. But as we saw with the math, it's more than enough to dramatically reduce the peak force and save your screen.
So, when you really boil it all down, the key isn't about being tougher, it's about being slower. It's about engineering a way to make the crash last just a little bit longer. Now that you know the secret, I want you to look around. What else in your world is secretly designed for that perfect, soft landing?